It hasn't started recording yet. Okay, now it has started. So welcome to today's tutorial. We'll be going through semester test 2, 2023, the SSA, right? So it's a utopian, whatever, society has been ramping up its study of ant behavior. They have formulated several rules and need to simulate them to determine whether they are accurate. By simulate, right? A simulation, right? It's like you create an environment that mimics that thing that you wanted to do. So, for example, you want to learn how do you want to see how a car is how a car looks when you drive it. You can create a game, whatever, to simulate that, right? To basically mimic or copy that. That's what they want you to do here is to simulate, basically make a simulation of that to determine whether they're accurate and simulate real and behavior. So this app that we're about to make, or this practical, right? You're gonna simulate or mimic how the ants behave, right? An ant. The society contacted you to help create such a simulation. The following diagram describes the simulation setup and features. So they're always gonna give you some diagram, right? You see this diagram, and then they tell you what the star means, what this circle, the white circle means, what this black circle means. So you need to always read this part over here to get a better understanding. So ants, these are white circles that we can view. Remember that this is a text-based game, right? Meaning that we can't, how do I put it? We can't we're not doing graphics yet, right? By graphics, I mean you can't actually download you can't create a 3D image of an ant and make that game. To be honest, that's very complicated. So that's why we're gonna make a console application. So we're gonna look for symbols that are gonna represent those things. In this case, in this diagram they gave you, it's a circle. We can't really put a circle on a terminal, so yeah, we for you guys, it's still first here. You can't do that. So we're gonna use a different character. Maybe for a circle, we use C. C represents a circle. So that means in our game, if we see the letters C, we know that's a circle. Or that's an ant, I mean. Or you can choose the symbol A for ant. That's up to you. You decide what your program is. Your practicals for your solutions, right? For everyone, they're going to be unique. They're going to be different. So I wouldn't advise you to cram my solution because that's not going to help you in any way. You need to decide which symbol will you use in your game. So now I'm gonna have my ants. Those are the circles, and then empty, yeah, white circles, right? Empty circles. Then the black circles, right? That's what we call the ant colony entrance, right? Those are the black circles. And then where are the stars? So the stars are the food sources, right? Basically, I think that's where they get the food. Yeah, I think the stars represent the food that the ants eat. So now I'm going to read this. The simulation does not require the user to control any of the game's features. Hey, this is not the right one. This one over here. This one over here. This one will chow you. This one. And this one doesn't play. The one basically what they're saying, right? There's no move in the game. There's no options to move, right? Like move the player, whatever. They said everything should be moving on its own. Hence, it's called a simulation. So the simulation does not require the user to control any. So the user is not required to control any of the game's features, right? So I'm gonna highlight this while the simulation runs. So that means it's gonna run on its own. However, simulation configuration is controlled through either command line arguments or user inputs. So that means before it starts, is the players, right? They start, or the ants, before they start moving on their own, you must get some options from the user to basically to give it settings so that it starts moving on its own. The simulation aims to see how many rounds it will take for ants to gather all food near a nest. To be honest, it's not the right break. I would have decided, I would have preferred we do a different one, but let me, because this one, when it moves on its own, it's advanced. It's like you need to start with the basic game on how to enter options. So I need, I think your practical eight, you're supposed to move the players, right? So me doing this question paper wouldn't help. I didn't know that it was, yeah, I honestly didn't know. This one, they want the players to move on their own. Can someone send me practical aid? But I'm not going to what is this? I just want to check that question paper to see. Um uh does not require the user to control eyeball. Hey, it's like they love simulations these days. Let me say semester two is 2A. You must move a player controlled operator around. Yeah. They said you must move. Yeah, there's moving here. Yeah. So let's do this one. Yeah, let me not do that other one because the simulation is a bit advanced, right? So let's see. Let's do a different one. Because if I do this, the ones that moves, the one where it moves on its own, then if your practical requires you to enter the options, then to be honest, I've actually not answered your questions. So yeah, I don't want to do that. I want to do an example whereby it's similar to your prec, whereby if in your prec there's movement, in this past paper there should be also movement. So the utopian city has been covered by a dense mist, which has made it difficult for people to navigate the area. The rise of this mysterious mist coincided with a citywide power outage, right? Blah 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 blah. Doesn't matter. So we have this game, right? I'm not gonna be reading everything. So we have this game. This is how it looks, right? We have symbols here like the triangle, the circle, and the lightning and the star. So we need to know what they are, right? So the star is the main switch, right? You need to use your imagination. And then the batteries are the lightning bulb. And then the operator is the black circle. And then exposed wire is the triangle. And then torch visibility radius is the large circle. Basically, it's visibility, the torch visibility area. As you can see, even though it's a circle, it doesn't mean you will draw the circle. That's not what it means. It means this, where is it? The black circle, right? The operator. It has these things that are within its radius. So as you can see, they're not they're not painted in gray, right? To show that this circle represents this radius, which is this 6 squares, right? That's the whole radius, the 6 squares. But excluding the center, this so that's not six. What am I saying? 369, 8. This 8 squares, right? These 8 squares, they represent the radius. Basically, it's like you are within my radius, within my you are in. If you know the word proximity, right? You are in proximity, something like that. So yeah, it's like how do I put it? It's like imagine this is you, right? This is you over here. This is your friend over here. Your friend, the closer they come, you can say that they're within your radius. The closer they come to you, they walk towards you. You can say they're within your radius in a way. So yeah, that's not important for now. We'll look at that when you're coding. You must move a player controlled operator, right? So that means by player controlled, right? That means that in your terminal, right, you're gonna have options for to move the player, like move up, move down, move left, move right. So basically, you're making a full game here. Operator around a two-dimensional array, right, or a two-dimensional area. Remember, we talked about Cartesian plane. Think of this as the Cartesian plane, right? You see this lines that go down. Think of that as the y-axis. The horizontal lines, think of those as the x-axis. So therefore, it is true that this is a 2D game. we're in a 2D world whereby we have two coordinates that point to a physical object. By physical objects, is these circles and these stars and this lightning. Those are the objects in that world, right? Um, yeah, playing area in the game. You win the game when the operator finds the main switch. So this part for the game over, right? We need to know when does the game end? When is the game over? It's over when the operator finds the main switch, meaning when the black circle, where's the main switch? The star. So when the black circle finds the star, basically it meets the star, then the game is over. You're done. You've won the game. You lose the game if the operator's torch, right? You lose the game if the operator's torch runs out of batteries or the operator steps on a exposed wire, which makes sense. Exposed wire is the triangle. So it's, if you step on a wire, which is this triangle, then it's game over. Or you ran out of batteries. So that means when the game starts, you're supposed to have a specific number of batteries. That's what I'm assuming. The operator's torch, right? The operator's torch can, yeah, you might not, let me see, you lose the game. Let me highlight here with a different color. Why is this important? Because we're gonna write it in code. That's why I'm highlighting this so that I know what is the game over, what is when you win the game. That's very important. So that's why I'm coloring here. Let me use that color. The operator's torch can only stay on for a predefined number of moves, right? It runs out of battery power. So that means, like I said, you can have an integer whereby every time you move, it decreases. We decrease that integer, meaning the batteries, right? Every time you move, you are using it's you can imagine. See now, guys, normalize muting because next time I'll kick you out. I'm not gonna repeat this because now you see we've been disturbed. Now I might have lost my train of thought and forgot what I was explaining. And then I'll also waste time having to explain that please don't forget to mute when you enter the session, which is a waste of time, whereby if you could have just entered peacefully, quietly, and I just continue teaching. The operator's torch can only stay on for a predefined number of moves until it runs out of battery power. So that means it can only stay on for a specific number of moves. So we're going to have a variable for number of moves. We're going to initialize it to some number of moves, right? Then we use those numbers, we decrease those numbers every time the user makes a move. So basically, you have a maximum number of moves in this game. Every move you make, basically, if you move up, left, or right, or down, or diagonally, if there is that the player is able to move diagonally, then you should decrease the number of steps or number of moves by one every time you move. Batteries are scattered, right, around the power plant, and the operator must pick them up while looking for the switch in order to keep the torch working. Oh, so you're gonna look for the switch. The switch keeps the torch working, right? If you don't find the switch, then eventually you're gonna get a game over because the torch runs out of batteries. So that's basically what we need to understand about the problem. It's a small problem, like just small. You need to understand the whole idea of what's going on because we're gonna need to go back there once we get to our application is kind of long, right? You must place the logic of the game in the mist space namespace, right? So you need to place it in this namespace. The size of the world, the probability of a battery, and the probability of an exposed wire must be provided via command line arguments. So we're going to use command line arguments. So what are command line arguments, right? Before we start, let me explain a bit about command line arguments, right? So in order for me to explain about command line arguments, I would have to, what is this? I would have to make a small C++ application, right? So let me do this. Let me make a small C++ application, which just takes in two numbers from the command line arguments and it adds them up to find a sum. That's a simple application. So I'm gonna create my okay, let me do it this way. Let me go here. Yeah, so let me create the CPP file here. So I'm gonna create a CPP file. So I'm gonna say new. Come on. New text document, main, and then instead of .txt, it's .cpp because it's a C++ application. Then I'm gonna right click and open it in Notepad++. Then I'm gonna say hash include IO stream int main this come on, right, and then I'm gonna return 0, right? So this by C++ application. There's two ways you can get input from, okay, not two, more than that, maybe three or four, somewhere there. So there's multiple ways you can get input from a user. You can get input from a user or from a programmer, right? To get input from a programmer, command line arguments are useful when you the programmer, you want to test the application. That's when command line arguments are useful. How do we tell C++ to accept command line arguments? We pass here we pass here a type, right? Well, to be honest, you'd actually have to pass in a what is this, a string, but inside, since C++ is like a child of the language C, because before C++ there was the language called C, right? If I go back here, before C++ there was a language called C language, right? And then the authors of C++, they realized that C language, right, is a bit behind. It doesn't have OOP. Then they came up with a language called C++. Why the plus plus here? If you remember plus plus in C++, it means to add by one, right? So it's just a funny joke in a way, but it's like they took C language, then they added one thing in that language, which is OOP. So that's basically it. So that means C++, it is, you can write uh, statements that are from the C language inside the C++. So let me show you. In C, you can print, to show you that I'm not lying. In C, you can use the function called printf, right? Followed by the string you want to print, right? So in this case, I want to print, I think it's optional. I'm not sure about the other parameters. I think it's optional. Let me say hello world, right? And then \n, right? This is not C++ code. This is from the C language, which is the parent. You can think of the C language as like the parent of C++, and then C++ is the child. So I'm gonna go back to my file here, and then I'm gonna open it in terminal. I wanna run using G++, right? Let me check if G++ is installed. Yeah, it is there. So cls, then G++ main.cpp, send it to main, and then yeah, you see no errors, right? Then I'm gonna say dot / main, and then there's the output hello world, right? As expected. But then I wrote code that's not C++. This is C. So that's why we're gonna use a bit of C in our C++ to create the string. But just know that the function expects a string. But then that's how you represent a string inside C. So it's gonna use the C concept. So here we pass in what we call a char pointer, right? But since how do I put it? Yeah. So here we want to pass an array of what is this? An array of strings. So in C++, right? In C++, you can represent a string in one of two ways. You can create a char pointer like this, right? Or you can say string type. You can do it in one of these ways. But then if for your parameters here, right, to get to command line arguments, you need to pass into main function a one-dimensional array of strings, meaning a string pointer. Because why pointer? Because the size varies, it changes. It's not a fixed length. Because you can pass two command line arguments, or pass three, or pass 10. You can pass any number of arguments, right? So you'd have to make it a pointer so that it's dynamic. So if this represents a string, then a one-dimensional array would be me adding an extra pointer there, because char pointer just means string. So if there's pointer, char pointer pointer, it means this is an array of strings. But this is the C way of doing it. And then in C, if we were to do the C++ way, you can do it this way. But then I wouldn't advise you using the string, because I've never seen them write it there. I've never seen a developer who wrote C++ code. So we actually have to use the C language way. So I'm gonna say pointer pointer there. Then I'm gonna call it args, right? You can call it anything, to be honest, it's up to you. But then args is a more reasonable name, because args is an abbreviation for arguments. Remember the document, it says you need to pass, where is it? Uh, where is it? Where's that option? Is it there at the top? Where's that? Where did I see this thing about? Oh, yeah, via command line arguments, right? Yeah. So there's the word arguments. If you remove the letters from U to T, you're left with args, which is just an abbreviation for arguments. So that's why we call it args. So don't give your own spiritual names like S, they don't do that, because it's going to confuse people who read your code. They might be in a bad mood and not mark it. So I wouldn't do that if I were you. And most of the time, this command line arguments, right? We won't change them. We are just passing them inside C++, right? So since we won't change these command line arguments, right? I'm gonna put a const there. So const char, because they're going to be constant, they won't be changed. And then since, remember, this is an array, one-dimensional array, right? So that means to index into the array, I'm gonna say args index 0 and so forth, right? Then to get the values like that. So most of the time we're gonna get the value, we won't change it. So that's why I'm gonna put const there, because we're not gonna change the information. So to test it out, right? I want you to understand something about command line arguments. The first, basically the indexes. At index 0, it stores the name of the file. Basically, remember in C++, right? We write the code inside C++, but the computer doesn't speak C++. He doesn't understand that language. So someone needs to go and translate that C++ into a language that the computer can understand. That's why we use the compiler G++, because we're trying to translate it into a language that the computer can understand. And we get a .exe file. There it is here. If I look at this in Notepad++, right? This is the language of the computer. You see how complicated it is? So that's why we always have to translate it. This is how, look at this program, just to output hello world. This is how complex this thing is. It's a lot. And look at how many lines are there. Let me show you. 1,944 lines. Just to display hello world. So yeah, that's why we use C++. So the next time you feel like crying and saying C++ is hard, just know some developers back in the days when C++ was not there, they were doing this. They're writing it from scratch like this. You can imagine how much pain they went through. So from now on, don't be moaning and complaining. No, this thing is hard. It's not. It's not. If you think this is hard, try going doing actuarial science. Maybe you'll come back and appreciate. I don't like people who complain. Don't complain. Nothing is hard. No one's smarter than another person. We are all smart. It's all about who makes more effort to study. So just go and study and understand everything. So the name of the file is that executable file. So it's the .exe. That's the name of the file. I think so. Is it the file? Is it main? Is it CPP? Yeah, we'll double check. I think it's the executable or CPP, but it has to be executable. And then from index 1, right? That's where the arguments start. So this will be the first argument, right? Meaning first input. Another word for argument is input. This is the first input. And remember what I said, this is an array of strings. So if you want to add numbers, you have to convert it to a number. Don't forget that to convert. We're going to need to convert that to a number. Then you can go up to infinity. There's no limit in how many arguments you want. So I think I'm forgetting. Yeah, there's two inputs I'm forgetting. I think there needs to be another one here called argc. Yeah, I think it's either vice versa, or I haven't done command line arguments in a while. And they're not there in the textbook. I don't think I've seen it. Yeah, I think you take two arguments. Yeah, the strings, which is the inputs, right? Then we also take in int argc. What is argc? It's the argument count. So arg stands for argument, c stands for count, meaning it counts how many arguments are there. So that's the variable that stores how many arguments are there, just in case you want to use a for loop. So if you want to go through all of them, that means you have to use a for loop and then use this as the size, which is argc. Then to show you that what I'm talking about works, right? Let's just output what's at index 0. So I'm gonna say cout. Okay, I'm not using namespace standard, so I need to specify which namespace I'm getting cout from. So cout args at index 0, and then end of line character, but it's from the standard namespace, right? Simple app, right? Then we're gonna run it again. So we need to translate it again. Remember, we've updated our file, so we must do the translation again. So G++ is going to translate for us the file named .main.cpp, and then send the result into a file named main, then press enter. And then something is wrong. First argument of should be int. Oh, yeah, I told you guys I haven't done this thing in a while. It's vice versa. You start by putting the size. So it's like this. Yeah, you start by putting the number of arguments into argc, followed by the number or the array of strings, which is the arguments themselves. Yeah. I hope they included it in the textbook. I'll check. I'll check that other textbook. Remember, I gave you two textbooks that you can read. I'll check the other textbook and see if it's there. If it's there, then yeah. Yeah. So you see, it's not complaining anymore, right? Let me teach you something about command line arguments, right? Let me show you. Command line arguments, right? It's when you do this /main. Yeah, it's the executable. Yes, index 0 is the executable. You see, this will count it as the first argument, which is at index 0. Then space, then you put in other inputs. For example, you want to get the number of rows and number of columns. So you can say 35. No, that's too big. 10, or say 25 space 25. So C++, right? That args variable will store this at index 0, and then 25 at index 1, 25 again at index 2. But then we're only outputting at index 0. So you see that the output will be a bit different, right? It won't output all the numbers or all the command line arguments. So it's going to output the command line argument at index 0, which is the name of the executable main.exe. So I'm going to press enter. And then there's the file, you see, main.exe. It just also appends on the full location, right? Don't worry about that location. It just adds it there so that it knows where it's exactly located, which is true because it's inside code blocks project. You see, that's my folder, code blocks project, and then there it is. So it appends the full location. If you click here at the top, you'll see the full location. There it is. So now you see that I wasn't lying, right? So now let's output all the arguments. To output all the arguments, right, I would advise you use argc, right, argument count. I would advise you use this. This is going to be very useful so that you don't exceed the index. You don't go out of, you don't exceed the indexes, right? So let me do a for loop and display all the arguments. So I'm going to copy this. Then I'm going to say for int I is equals to 0, I is less than what? Argc. I++, because argc stores the number of command line arguments that I'm getting from the user. Then I'm going to use I to index and go through each argument, right? Before I display the argument, I'm going to display the string, this is argument at index, right, at index, but then I can't just put the index there. I need to pass the index, right? So I'm going to say at index, then I output the index, which is stored in the variable I. So variable I, so output I, space, no, what am I doing? So let me remove that. So I wanted to say index 1, index 0, index 2, index 3, and so forth. Then after showing the index, it should show a colon, right? And then after the colon, you should output a space. Then after that space, it displays that index, that argument at that specific index. So now I can paste my code there. Instead of argument 0, I put I, so that it keeps on updating to find the next argument. So if there's 2 arguments, it's going to output two lines. If there's 3 lines. If there's 4 lines, because I'm using argc, which stores the number of argument values, right? Or arguments. Then I'm going to go back here. Just make sure you refresh so that your main.cpp has the latest changes you've made. So refresh. Let me also check if I've saved here. Yeah, I've saved. You see that green line over the side. If you haven't saved, it's going to become yellowish. So let me go to this line, or orange. Yeah, it's going to become like this if you haven't saved your changes. So I'm going to click save to make sure it's saved. Then I can just refresh here to just be sure. Then I'm going to open in terminal. And then let's do, yeah, that's why batch file is important. This thing of having to type this all the time, it's quite annoying. So let's run it, right? Then I'm going to say ./main to execute that main file, right? Space followed by all the extra arguments, how many arguments I want. Let's say I want to take in the number of rows, which is this, followed by the number of columns, 25, followed by the probability. I think also followed by another probability, let's say 5. So now I have how many arguments? So basically C++ is going to count. This is 1, 2, 3, 4, 5. Then it's going to store 5 in argc. But if this was not there, it was going to store 4 in argc. So it just keeps on updating itself based on the number of arguments that are there. Remember, at index 0, it always refers to the name of the file. So that's why we're always going to skip index 0 and start at index 1, because we don't care about the name of the file. So let me output this. So there's my output. As you can see, index 0, position 0 is the name of the executable. Then at index 1 is this, at index 2 is this, at index 3 is this, at index 5 is this. But then don't forget, these are all integer, they're all strings, they're not integers. That's why in your practical, there should be a function to convert from a string to an int. To be honest, you don't have to put it. Technically, you don't. But the thing is, there's marks for it. So you have to declare it yourself, because there's already a function that converts. It's called, it's A to I, then A to L, then we have A to F, I think. I'm not sure. Let me check Chrome, right? Let me check the documentation. It's A to I function C++ reference. Where is it? Yeah, it's this one over here. Yeah, A to L, A to I, yeah, A to LL, meaning it converts. Yeah, you see, these are the functions you can use, right? There's a function, and it's inside cstd lib. They told you it's defined in the header file cstd lib. So you just include the cstd lib, then you'll have access to these methods. What do these methods do? It's called A to I. This I over here, it means integer. This L over here, it means long. This LL over here means long. Remember, we talked about char pointer, right? Because remember, C and C++ is technically the same thing. So strings, they actually represent them as const char pointer. So that means this function takes in a string that you want to convert. So A, it just means, I don't know what actually means, but you can view it as like a character. You're converting a character or a string to an integer. There is this function already. Technically, you can use them, right? But like I said, I think there's marks for that. If we check Okay, technically there isn't. Let's check the mark sheet. Okay, there isn't. Maybe other past papers have. We'll check other past papers that you're gonna do. But most of the time, do they have marks for that? No, I doubt it. I think there's marks for allocation, deallocation, and basically all the marks they mark each function that you have. You're gonna need to have a move player function, you need to have a allocate function, a deallocate function, and an update function. Those are the four main functions that I needed. So yeah, technically you can actually use these methods over here. A to I, A to L, A to LL, you can use them. Yeah, let me show you an example here. Oh, this is the implementation of the function. Mm. Yeah, it's quite complicated. We don't care about the implementation. We want to see how it's used. So this is how you use it, right? Um, blah, 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 blah. Yeah, C++ is kind of complicated sometimes. So don't pay attention to things you don't understand. Ignore the things you don't understand. But remember, touch with the curly braces on how to initialize variables. So they're using that approach. So, and it's in the standard namespace. So A to I, and they're passing S, which is a const char pointer, which is a string. Then they are converting it and putting it into the integer variable I. And yeah, yeah, you should use const int. Let me think about it. Can it be a const int? That's optional. Yeah, you can use const int or not. That's optional. Then there's other ones, right? There's S to I. Hmm. Oh yeah, there's other ones. Yeah. So yeah, C++ is quite broad. You see that there's a lot in C++. There's also S to I, which converts a string, not a const char, but it should be a string. Yeah, you see, it's in the string header file. So you pass it a string, an actual string type. But then we are using const char, so we're gonna use the A to I functions, not the S to I. The S to I, they are from the C, right? No, the S to I, they're from C++. The A to I, they're from the C language. And if you look at our function, right, we said const char pointer. So we're gonna use that approach, the A to I. Let me show you what I mean. So after this, right, after displaying here, what I'm going to do is I'm gonna say, okay, let me just output an end of line character here. So C out std end line, right? So I'm gonna just to make to have some space. Then I'm gonna show you that what I'm talking about is right. These are strings, not integers. So you have to cast to an integer. So let me say std out, and then I'm gonna add index at index 0. Not index 0. Remember, index 0 is the name of the file. You always start at index 1 plus args at index 2, right? But then this is not always safe, because what if the user enters one argument? Then it's gonna crash, because that means there's no position 2. You need to always check the indexes before you output or use them, because the user can enter the arguments that are less than what you expect them to enter. So you'll notice that we're gonna have if statement to check if how many arguments the user has entered. And remember, the variable that stores how many arguments is argc. So I'm gonna say g++ main.cpp -o main, and then it's gonna crash somewhere. What is it saying? Invalid types plus to binary. Oh, yeah, these are strings. C++ is kind of annoying, Shem. These are strings, right? Oh yeah, it's not yeah, I see. I get the error. So I won't be able to do what I'm trying to do. But I technically should. No, it shouldn't. It's right. Yeah, it shouldn't. Yeah, it shouldn't. Yeah, but it shouldn't do what I wanted to do. But yeah, this is crashing because the plus operator, it doesn't work for whatever you're trying to do. These are not strings, right? If you want the plus operator to work, you have to actually make this, you have to make args to be an array of string, meaning you have to include string header file. So now I can't demonstrate what I was saying, what I wanted to show, but just know that args is of type string, right? You have to cast it back to a number if you want to work with numbers. If your preg works with numbers, which is true, because your game is gonna work with numbers. So let's start. our, okay, before we start, let me, yeah, we can create the namespace and then I'll explain while we go. So let's create the project, right? We're gonna need a namespace and the header file and the CPP file. So let me double check something here. So we're dealing with, what is this? We're dealing with the mist, right? So I'm gonna call it mist.h or mist space.h. It doesn't matter what you call it, but try to make sure it's related to the problem. So I'm gonna open code blocks, right? Yeah, I'm gonna explain everything. Like I'm gonna explain how we achieve this. I'm gonna break it down. I'm gonna show it to you. So project, next. What is this now? Project title. It's computer science. Let me write it in full. Vortex Academy, computer science 1A, ST2. Which year is this one again? 2023, paper A. Paper A 2023. And then next, and then make sure you choose GNU GCC compiler, and then leave everything as default, then finish. Then I'm going to create my header files. So I need the manager to show this, then open my CPP file, close. Then I'm going to create the header file in the CPP file, right? Because we can't, why do we do that? We can't put everything inside main. Our code is going to be too long and hard to understand. So we're going to create a header file and the CPP file. So header file, I'm going to call it mist.h because they didn't tell us what exactly to name them. So we just put in the names that we feel comfortable with. Then select all, click finish. Don't forget to select all. If you forget to select all, I would advise you to delete it and create it again. Then CPP file, it needs to be named exactly the same way we've named a header file. And then just change the extension from .h to .cpp. Then include it to my project. That's what these three dots do. And then click all, and then click finish. Then don't forget to include the header file here, mist.h, right? There's mist.h. Yeah. So let's see what we need to do. So let's start with the very top part there before let me see. Yeah, this is the mark sheet. I don't know how come I wasn't seeing the mark sheet. I want to see if there's marks for the function. Use of assertions, not what. Dynamically allocated structures, there's 5 marks. So you need to also use record structures here. Then there's also bonus, but we're gonna get to the bonus later. Pseudo random number generator. So the function to generate a random number is worth 5 marks, 5%. So yeah, to be honest, you can pass this paper I want you to understand something about com sci, especially even both semesters, even both years, this year and this year and next year. Com sci, don't worry about output. Worry about the mark sheet. If they say create this function, create that function, because they mark functions, not output. I want you to notice something here. Output is only worth 5% of the paper. Basically, for them to see your game, it's only worth 5%. So don't be stupid and waste time trying to display it. The main goal is to make sure it runs, it compiles. That's number one. Number two, make sure you have all the marks, the functions and everything. They said here, you need to use structures. So you need to create a record structure somehow. Allocation, there's a function to allocate. Initialization, there's a function to initialize. Deallocation, there's a function to deallocate because you're most probably going to work with pointers. Then command line arguments. You've updated your main function. So basically, you see this 1 mark here. It's going to be this part over here. Where's my notepad? This part over here, it's worth 1 mark. Passing these two parameters is worth 1 mark. So try to make sure you answer as much as you can. Don't lose hope and think it's not about output. Output is worth 5%. of the paper. That means 95% of the paper is worth on functions and variables. So when I focus on functions and variables, output doesn't matter because you're most probably not going to have a game that's running. So I wouldn't advise you to focus on output. Unless if you're strong enough, you've practiced enough, you've listened to what I was saying, you do homework, you do everything, then you can worry about output. But output should be the last thing you worry about. Once you're done implementing all your functions, then you can focus on output, which is your main. Then you try to make it display. If it displays, then you try to see if the movement is working. So there's also one mark for header file. Just creating the header file, there's one mark. And putting those functions there. One mark, literally one mark. You see how easy it is to pass this paper. Naming of variables, based, you see coding style. We talked about camel case. There's mark for that, for following the rules. You see what I was talking about, the making your code beautiful, the curly braces, putting it on the right line. There's a mark for making your code beautiful. One mark. There's a mark for comments. There's a mark for constants. There's a mark for problem compiles without issuing warning. So if without issuing warnings, right, that means your code, you see here, let me show you what warnings are. So let me show you a warning, right? Let me view my logs because I'm also going to teach you how to approach the project, not just to write it. You see, there's no warning here. So if I was the one writing this, I would have gotten one mark for that because there's no warning here. Now let me create a variable and not use it. It should give me a warning. So let me build it. You see, now it says warning. So that means I get 0 for that part because there's at least one warning in my code. So that's what they mean by that one mark. Then you have standard namespaces, abo hash include, abo cstdlib, all of those things, they're worth one mark. You putting that there is worth one mark. System library inclusion. Oh no, it's 4 marks. No, it's the namespace. Yeah, when you say using standard namespace, that one line is worth one mark. If you include your libraries and everything, your cstdlib, your ctime, your what, that's worth 3 marks, all of them. Indication of successful termination, basically an output that says your program, the player has won, the player has lost. I think that's what they're talking about there. That's worth one mark. It looks weird, right? It looks like there's easy marks here. Like how do I put it? It's like it's not easy marks. It looks like these marks are hard to get. There is. Break it down. Make sure everything that's on this mark sheet, you have it in your code. And don't worry about output. Output is worth 5%. It's not worth your time. You can't sacrifice 95% for 5%. Don't be stupid. So even if I did tell my students last year, some got 90 something percent by having a main that is hello world. They got 90 something percent by having a main. And when the tutors ran their code, it outputted this hello world, and then they passed. They got 90 something. So output is not the main goal of this project. It's not. Code is what's important. You decide to do your own thing. Hey, good luck to you. Trust me, it makes your code not to run if you try to do output most of the time because you guys don't practice code. So most of the time it crashes when you try to do output. So I would advise you to leave it. So we have you must place the logic of the game in the mist space namespace, right? So I need to copy this namespace. So I'm going to go inside my header file here. Then I'm gonna create the namespace, then this, and then mist space, right? That's the name of the namespace. Then I'm gonna go to my question paper. Then we're gonna look at the different things that I needed, right? I'm gonna teach you how to answer these questions, and you're gonna see that every time we answer this question, there's gonna be a pattern. Technically, you can cram this code and pass and get a distinction with just cramming, but I wouldn't advise that. Try to at least have at least 80% understanding of what's supposed to be done. Then the 20% maybe you can cram it. So let's see. So initialization. What I would advise you to do, right? The part that says initialization, create a function called initialize. The part that's written move, create a function called move. The part that's written update, create a function called update. And then the end game is for ending the game. You don't have to worry about that. Then if you've initialized, remember initialization, right, is the same as allocation. So if you have initialization, you need to have, or if you have allocation, you need to have deallocation. So that means I'm going to have one function here for allocation, two for moving, three for updating, and then four for deallocating. So most of the time it's going to be those amount of functions, right? So let's see how to approach it. So let's start with the initial allocation function. I'm going to call it allocate, right? And then I'm going to have another function called deallocate. You can have allocate and call it destroy. That's up to you. The size of the world and then the probability and the blah blah. So these are the number of things that they expect the function to take in. Your function must take in the size of the world, right? Number one. But before we continue, we need to create what we call a two-dimensional array. So if you look at this code, right? If you look at this game world, so yeah, to be honest, this thing needs it for you realize that maybe this session might end with us having written a few lines of code, because there's a lot to explain. So let's look at this game mode, right? How do we achieve this? So I need to open Notepad++ and explain it to you. So I'm gonna delete this and then copy this, do this. So in the game mode, right? How our game mode works is that we basically come up with integers, right, that represent each character in our game. So I can have P that represents a player if my game is a player. But then let me do this instead. Let me go back to here. Okay, I need to close this. Let me go back here. Where is it? Yeah, let me go. Not here, here. So these are the characters in our game. We have a star, we have batteries, we have an operator, we have wire, we have a torch radius. Torch radius, right? That's just a radius. It doesn't mean that's an actual player or that's a character in the game. It's not. You'd use an if statement to check the radius. That's what radius means. We always use an if statement to check that. Or a for loop, that's up to you. So that means our actual characters in the game, it's star, that's one, two, battery, three, black operator, four, exposed wire. So let's do it one step at a time. So I'm gonna have a star. It's up to you how you come up with characters, right? You're gonna see how I approach my game. My game, right? Remember, if you look at your game, notice something with your game. We also have these circles. You see the squares, right, that are colored in. But then you see, they didn't talk about the squares. They didn't mention the squares. So don't worry about them shading them in. It doesn't mean it's a game character. It's not. It's the same as these white squares. They're exactly the same. They just shaded them in so that why did they do that? So that you only focus on this part and understand what it means, this part. So basically, this white square is the same as the gray square. It takes a lot of understanding to do this game, to be honest with you. It takes a lot of understanding. So let's ignore that. So you see the squares, this empty square, empty. I'm using the word empty. For example, this part is empty, is not occupied. This part is not occupied. This part is not occupied. This part is not occupied. The gray squares are not occupied. So we call that an empty space. So for my game, I'm gonna use a dot to represent the spaces that are empty. So empty space, right? Meaning the spaces that are not occupied. And I'm gonna use the integer 0. Basically our game, right? We actually use integers, but then those integers we allocate symbols for them so that it makes our game easier to run. I'll show you why we need symbols, because people are bad at numbers. That's why symbols are better. So dot, for me, dot is an empty space. Then main switch, which is the star. I'm going to go here. So main switch, that's the star. So star, let me use the letter S, right? It can be small letter S, that's up to you. Let me think about it, small or capital. Let's use capitals. So capital S, this will represent the star, right? Or the main switch. Main switch. And this will have the integer number 1, right? That'll be yeah, you find out later on when I start showing you. Don't worry about me having a number in the letter to represent one thing. It's actually like that in the game. So I have batteries, which is lightning bolt, right? So battery, I'm gonna use B for that. I'm gonna use that for batteries. And then I'm gonna use an integer number 2. Then we have operator, which is the operator black circle, right? So I'm just gonna use an O for that. To be honest, it's up to you. Remember, this is a game. It's up to you. You can in your game. That's why I don't advise you to cram my code. It's not gonna end well. Your code is gonna get errors everywhere. C++ is not I'm gonna repeat this again, right? We are now at university levels. You're no longer kids. It's not a high school, and they don't care about you. They don't give a fuck about you guys. So if you don't care about yourself and UJ also doesn't care about yourself, who's gonna care? So you need to take yourself seriously because UJ doesn't care about you. I'm gonna repeat that. It doesn't. UJ is a business. They care, the main goal that they care about is you paying. If you want to see UJ doesn't care about you, right? Owe 1 rand to UJ. You won't see your academic record, which is basically your results. You won't see them. Just because you're owing 1 rand. UJ is a business. They don't care about you. Go start. This is not a joke anymore. There's no time to joke around. This is the semester test 2. You'll fail dismally. I've written this paper. I've sat next to students who end up getting errors one way. The whole screen is full of errors. And then they end up leaving the venue failed because they didn't take themselves serious. When I say go read the textbook, I mean go read the textbook. When I say do homework, go do homework. Or else if you want to end up in tears. I hope I don't have to repeat that. So operator, I'm going to use O for that. So O, yeah, I was explaining you can use a star for operator. It depends on your game. My game, I'm going to use O for operator. Then I'm going to represent that with the number integer 3. Then for exposed wire, which is a triangle, yeah, it's the triangle. So it's a wire. So I'm going to use W. I'm making my game easy for me to understand. And then it's going to have the integer 4. So that means in our 2D game, right? Remember, it's a two-dimensional plane, right? It's like a Cartesian plane, two-dimensional. Hence, they give you the diagram here. You have the rows, we have the columns. So each row or each column is let's start with this circle over here. You see this part over here, the first square can represent either maybe a torch or whatever. It can or an operator or an empty space. And then this next one represents the next thing. But then each square, it actually we represent each character as an integer first. We need to represent it as an integer first. You might not see why, but then I'll explain later. So let's say, yeah, this is your game world, right? This is your game world. Don't mind the bunch of zeros, right? Remember the zeros. Remember what I talked about here. Empty space, meaning my game is too empty. There's no player. There's nothing. There's no character. Then let's say I place my. Let me see. Let me do this. Okay. I also need to understand something. The number of rows and columns. So this will be 1, 2, 3, 4, 5, 6. 6 rows, 6 columns, I mean, and 4 rows. For those who are going to major in maths and comp sci, you're going to do matrices. This is a matrix. So it can view to similar to a matrix. So there I have 6 columns and 4 rows. So now we understand that. So empty space is zeros, right? And I said it can be simple dot. So let's use a star. Let's put a star. We're gonna place these things randomly. So let's say I place it there. I put a 1 there because a star is represented by the integer 1. And then I put 2 batteries here, 2 batteries, the battery there and the battery there. Because the integer number 2 represents a battery. Then I'm gonna put a 3 somewhere there for an operator. I think we're gonna have one operator in our game. Yeah, it's gonna have one operator. So only 1, 3. And then we're gonna have a wire, which is 4, in integer number 4. So there's 4 there. So if this is my game over here, right? This is my game. To move a player or the operator, let's say we're moving the operator. We want to move the operator from this column to the next column. So that means this part over here, right? This 0 over here will become a 3, right? Then since this part over here, this first three is no longer occupied, listen to the terminology. It's no longer occupied. So that's an empty space. So we change that three to a zero. So this now, you see now it has moved. It has you can think of it as like walking forward. It has moved forward, one step forward, right? And then to move diagonally, that means it moves in this way, right? Or in that way. That's what we call diagonal. So for example, three can move diagonally downwards, meaning it moves to this part over here, to this zero over here. That means this becomes a three. It's no longer occupied. We change that to a zero. Trust me, this becomes way easier when you look at it, when you listen and pay attention to this explanation. Because when you start writing the code, you realize that we are just putting into code whatever I'm doing over here. But then I'm sure everyone can agree. This looks boring. Like it looks weird. Like what does now you're gonna keep asking yourself, what does a two mean again? What does a three mean again? You see, it confuses you. That's why even though each game character is represented with an integer, we will replace those integers with actual characters or actual symbols because people like which is you and me, we understand better when you see letters or we read words. We can remember better than looking at numbers. We are very bad at numbers. For example, I'll tell you to cram pie today. Can you cram pie? No. But then you can cram a sentence in paragraphs, right? That's way easier, right? Because that's how the brain is. There's nothing we can do about it. That's just how it is. So we need to use that to our own advantage. Since we are good at remembering letters and symbols, all those things. I say that the integer number zero will be represented by a dot. So that means everywhere where there's a dot zero, I replace it with a dot. So put a dot here, put a dot, 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 dot. I'm sure you can start to see that the game is starting to become like beautiful in a way. We can start to kind of understand now a bit better, right? Dot here, dot, and then dot, 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 right? Then what does the integer one represent? It's the star or the letter S. I chose the symbol S to represent a star in my game. So this will be a star S. Then two represents the batteries, so which is a B. So where there's a two, I'm gonna put a B. And then where there's a for three, it's an operator, which is I chose a capital letter O. And then four is a wire, so W. So now I'm sure both everyone can agree. This looks way better now. It's understandable, right? So that's why I needed to explain this. This is how we're gonna actually mimic this game over here. It's gonna look somewhat like this, right? Like this, depending on the number of rows and columns. But it's gonna look something like this. So yeah, that's the whole thing about it. That's the thing we're trying to achieve, right? And since if you understand something, right, since all of these are going to be, remember that what I said, the number of arguments, right? Let me go back to I removed it. The number of command line arguments, right? It varies, it differs. You can have 4 arguments or 3 arguments or 5. That's why we need to create a pointer array of integers, right? A pointer array of integers. So how do we achieve this in terms of programming, right? How do we create it in C++? I've explained some, so I've given you an example, right, of how you can achieve it. That means you can have an array of integers, right? So I'm going to undo this. So let me do this, undo it, because you get the whole idea, right? So I'm just going to undo it so that you see, well, why we do certain things. This is a 2-dimensional array, right? But remember, this is 2-dimensional. What are these numbers? What data type are they? They're integers, right? So I'm going to have a 2-dimensional array of integers, meaning int pointer pointer. Because remember what we talked about. Each pointer or each star represents 1 dimension. So to be honest, you need to actually create your array inside the namespace. You don't declare it anywhere else. It has to be declared inside the namespace. So I'm going to create my 2D array of integers. But then remember, because working with integers is difficult, we're going to replace each integer and give it a specific symbol. so that it's easier for the eyes for the user to work with to do the game. Imagine you bought a PS5 and you're playing GTA and you're seeing a bunch of zeros and ones on the screen. How will that help you in any way? It's just that to actually put those game characters, right, like a proper game, you would have to use a language called C sharp. Yeah, it starts with C because it's part of this what you call C family languages, meaning it's similar to C++. But then you have to create your own players. You have to draw them, like literally draw the characters. Do you see how complicated that is? That's why we make a simple game like this, so that you guys understand just the basic idea of it. Then let's create the array. So I can say int pointer pointer, and then give it a name. So I can call my array game world, right? Because it represents my game world. But okay, let me teach you something, right? You don't have to do it this way. I'm gonna teach you a technique. I don't know. Yeah, we did talk about type def. Yeah, we talked about type def, if you still remember. So type def, it's like using a different name for that data type. Why might I want to need that? Why do I need to do that? Because let me show you why. Because it makes my code readable. So I need to use type def and say type def and say int star, right? Remember int pointer, it represents that since there's one pointer there, it represents what I call a one-dimensional array. So therefore, I'm gonna say 1D array. That D for for dimension, one meaning one dimension, right? 1D, one-dimensional array. So therefore, I've created a new type, which is called 1D array. Then I define another new type, which is 2D array, right? So type def, instead of yeah, remember I'm defining a two-dimensional array. So int pointer pointer, right? Because it's two-dimensional. Since it's two-dimensional, I'm gonna say 2D array. But then I would, okay, this is not good, but it's fine. You can do that, but this is not good. You can capitalize these letters, right? To sort of like, oh yeah, yo, I remember. We can, okay, let's do it this way. Just say, oh yeah, you can't. 2D, yeah, you can't. Let's leave it this way. So I'm just gonna name my data types like this. But remember, C++ reads from top to bottom. So when it gets to line 7, it was already executed. When it gets to line 9, it is already executed line 7. But then didn't we say that this part of a int star pointer, it is a new name? This part of it is a new name. Didn't we say that? Yeah, we did in the previous line. So that means I can simply copy this and then put it as a placeholder here, like this, which means that this 2D array is a one-dimensional array of a one-dimensional array. So basically 2D. So 1D array pointer, because I've given this int pointer a different name, which is this name. I hope that makes sense. Because remember, our game is a two-dimensional array of integers, so we need to have that. So that means every time in my function, when I pass a 2D array, I just pass this type, this new name, so that it reads like that, 2D array. Then I go back to my notepad. Remember, we have each symbol, right? We have the 0 to represent that the empty space or the dot. One is represented by the letter S, 2 by B, 3 by O, 4 by W. How do we represent this in code? We create characters, right? We create an array of chars. So I'm gonna say char, and then I'm gonna call it since remember these characters, right? If you look at these characters, are we gonna ever change them? Like change them in the future and say, no, while I'm playing the game, can this star change to a symbol star? No, you don't do that. Once you have the symbols, that's why, excuse me, that's why I'm planning first. So that when I go to my code, I know that these things are fixed for my game. It's fixed. It's never going to be changed. So that's why I'm going to make it as a const array. So const char, because it's going to be constant. These game characters won't be changed. Because you can't be, imagine you're in the middle of playing FIFA 2024, right? or FIFA 25. You are playing FIFA, right? And in the middle of the game, Messi's face changes to Ronaldo's face. Is that possible? So don't do spiritual things. So you need to make it as a const char, meaning it's never going to change. Once we say this is the game character, that's the game character. Imagine you are playing a racing game, right? And then in the middle of the racing game, the car changes to a dolphin or a fish. Like that makes no sense, right? So you need to make sure the characters that you're gonna represent in your game, they're constant. There's no undo. So since remember how to name constants, right? Any constant you name it in all caps. So I'm gonna call this one's game characters, right? And then I'm gonna put that there, then I'm gonna initialize them, right? You can put the size here, it's fine, but there's no need because C++ counts how many things you've passed in the curly brace. Then it's gonna resize that array to the number of things that are inside the curly braces. Remember, you can initialize, this is another way to initialize the array. So how many things do I have? How many game characters do I have? I have 1, 2, 3, 4, 5. So I have 5. So remember an array, remember this number 0. I want you to notice a pattern here. 0, 1, 2, and 3, and 4. Are they not similar to indexes? They are, right? So that's why I created an array so that at each index, it's represented by that specific symbol. And these are chars, right? So I'm going to put them in single quotes. So I'm going to start with the dot, which represents an empty space, comma, followed by the star, which is it, because it's a, remember these numbers are indexes of the array. They can be used somewhat similar to an index of an array. So index 2 would be a B, symbol B, right? And then comma. Index 3 would be the symbol O, capital O. And then the last index, which is index 4, would be the wire, which is the W. So this is my game characters, right? And you can see that there is a specific index, right? Basically, the integer representative for it. So this is position 0, position 1, come on, position 2, position 3, position 4. So that's why I created an array, because in the array, these numbers, they actually represent indexes in an array. So that's why I created an array of my characters. Then I have those game characters. We're going to use the game characters when we are displaying the game. Oh yeah, we need the function to display the game. Yeah, we need a function to display the game. So we're going to have a lot of functions. So for now, I'm just going to create one function, then we're going to end the session. We'll continue tomorrow. I think it's important to have multiple sessions because it's like, as you can see, there's a lot to explain here. I need to break it down so that you guys can really understand what's going on. So I'm going to need an initialization function, basically allocate, right? But then I'm going to call it allocation. And it's void because most of the time it's going to not do anything. It's not going to return anything, but it's going to do something. Then I'm going to say void allocation or allocate. Let's just call it allocate because it allocates memory, right? Remember, we have a pointer here. We need to allocate memory on the heap. So these are my functions. What does it take, right? What parameters does it take? That's where we need to understand the question. So if you look at the question, they said it takes in the size of the world. Remember, they told you this is a two-dimensional world, meaning there's two dimensions. We have x-axis and y-axis. You can picture it in that way. So if I have two dimensions, that means I need to take in two inputs or two integers. So I'm going to take in two integers, which is the rows and columns. So int rows, comma, int cols. That's the size, right? That's the first thing. They say the size. And then comma, the probability of a battery. Basically, what's the percentage of a battery? What's the probability of a battery occurring in that place, right? So that's what we need to take. Obviously, it's going to be an integer because probability can be 10%, 30%, which is an integer. So int battery probability. I know my variable names are going to be a bit long, but I want it to be easier for you to understand when you read the code. And the last thing is the probability of an exposed wire. So probability of exposed wire. So comma int probability wire probability. And if you notice the way I'm naming my variable, right? I'm using camel case. So this would be the function, right? So this is the first function. This is going to help us allocate memory. Remember, we have a two-dimensional array here. That's the one that we're gonna initialize to be the size of rows and columns. Then we also need to initialize it by giving it default characters, right? Things like that. So there's pseudo-random number generation needed and things like that. Then we can go to the next function, which is move player, which is going to need enums, right? We're going to need things like enums for that. Also update, we need to update the game. So to update the game, you usually take in the the array itself, the two-dimensional array, which is the pointer, and its size, the rows and columns. So yeah, but we'll get to creating all the other functions the next session tomorrow. So I hope you pay attention to this part. You see this thing over here? This is what's going to help us come up with the code to even move the player, end game, all these things. This diagram, especially this diagram over here, this is going to become very useful for us. So yeah, this is it for today's tutorial. See you in tomorrow's tutorial, tomorrow's session. So yeah, this is just it for now. And I can't say, don't ask me for code. I can't send, the only time I send code is when we are done with full paper. That's the only time I'll send the code. So yeah, that's it. So let me end the session. Now I need to go and attend ComSci 2A students because we're also doing past papers there.